This is a pretty simple question if you apply the formulas correctly. A body with absorptive power A is equal to 0.75, surface area and temperature is given, is kept in a room at temperature of 27 degrees Celsius. We need to find out the net rate at which this body loses heat. So for solving this question, the first thing is that A is equal to E, where absorptive power is equal to emissivity of the object, we know that. Therefore, we get the value of E to be equal to 0.75. Now we know that the rate of emission or radiation of the object is sigma EA into T raised to power 4, where T is the current temperature of the object, and the rate at which it absorbs heat is equal to sigma E A into T naught to the power 4, where T naught is the temperature of the surrounding. This is derived from, if the object would have been at equilibrium with the surrounding, equilibrium means that they both have the same temperature, then the rate of emission from this object would have been equal to the rate of absorption of heat. Therefore, we would have got sigma EA T naught to the power 4, this is the rate of emission. This would have also been equal to the rate of absorption for this to be remain in equilibrium. Now, if the temperature changes, the rate of absorption will not change. Therefore, the rate of absorption is still sigma EA into T naught raised to the power 4. Therefore, from this we get the rate at which the object loses heat is equal to sigma EA into T raised to the power 4 minus T naught raised to the power 4. Always remember that this T is in Kelvin. Therefore, on substituting the values, this is the net rate of loss. So, on substituting the values over here, we get this is the net rate of loss of heat. This is equal to, the value of sigma is given to be equal, the value of sigma we already know, 5.67 into 10 raised to minus 8. The emissivity of the object is 0.75. Mind you, emissive power and emissivity are two different things. So the emissivity is equal to 0.75. The area is given to be equal to 600 into 10 raised to minus 4. And the change in temperature, we write it in kelvins. So this is not the change in temperature, this is T for T to the power 4 minus T naught to the power 4. Therefore, this is equal to 273 plus 227, that comes out to be equal to 500 to the power 4 minus 300 to the power 4. So the final answer comes out to be equal to 138.8 watts. So final answer for this question, that the net rate at which this body loses heat comes out to be equal to 138.8 watts. You should remember this formula, that the net rate at which the body loses heat is always equal to sigma EA into T raised to the power 4 minus T naught raised to the power 4. Remember this formula also. So we get the final answer as 138.8 watts.